So we're going to take a little bit of time and talk about fungi. They're heterotrophic, which means they can't do photosynthesis, so they have to get their organic chemistry, their building blocks, and their energy source from plants in some way. And I just want to talk about the different forms that they do that. It's September now, and you can see right over here that my squash plants, the leaves are not green anymore, they're white. And that's because the sprinkler system sprays these leaves, and as temperatures get cooler, it causes infection by this fungus. And this is a fungus that just loves these leaves. And under the right temperature and the right amount of moisture conditions, they're able to infect the leaf. And this is a really good example of parasitism, where one organism is benefiting at the expense of another organism. In this case, the heterotrophic fungus here is infecting this leaf and pulling out the organic chemistry for energy and building blocks so that it can grow and reproduce itself. So a really good example of a fungus pathogen, this powdery mildew. And at some point it will form spores, and I flick this leaf and you would see tons of spores being released, and they're going to spread around and try to find more leaves to infect through this process, through the cycle. The other strategy that fungi use is not parasitism, but decomposition and root symbiosis. So here's a mushroom that's coming up. This is a fruiting body. I'm going to break it open. You can see the pink gills, and that's where through sexual reproduction, spores are going to be produced from this plant. And there's some more over here that I wanted to show you. They're all around this tree and in the lawn. And there are three different strategies that heterotrophic fungi can use to get their organic chemistry for, again, building blocks to make their tissues and for energy that they need to grow. And the first we just talked about, which is parasitism, infecting other plants and just robbing organic chemistry from them, like with that squash plant. The next one is what we call saprobes. So there are fungi that are saprophytic, and that's what's going on here. These saprophytic fungi have a hyphal network, a thread system in this organic soil layer. You can see how dark it is. There's lots of organic matter in there with tons of energy and building blocks that could make fungal tissue. And these fungal network systems are releasing enzymes into the organic matter to break it down and to release that organic chemistry so it can capture it. And so this process is called decomposition, and the fungi is decomposing the organic matter to get the energy and nutrients from the organic matter, which is just mostly decomposed plant material, plant being the autotroph, that it needs to get its energy source. And then the last strategy is root symbiosis, and that's where a fungus will interact with a plant root system, and the plant will allow colonization by this network in the soil, this microscopic network that the fungus produces. And then it goes in and it colonizes the root, and the plant will do photosynthesis and send sugars down to its roots, and in that symbiotic relationship in the roots, where the colonization of the fungus is happening on the root, the plant will deliver sugar to feed the fungus so it can have the energy and building blocks it needs to make its tissues and cells. And then in exchange for that, this expansive network in the soil of the fungus will capture nutrients and water that the plant needs to live and to do photosynthesis.